So again, nothing different from what we've been doing the past couple of days for our warm-up problem. So we have -3 and -4/5. You'll see those little squiggle lines, that's called set notation. You saw that on yesterday's worksheet. It's just listing your x values next to each other, and they're always listed smallest to highest. It's the same thing. And they're just showing you your two different x values. Why do you think they use these squiggles instead of parentheses?
Because it's only x values.
What would, if I gave them was parentheses, what does that look like?
Oh, it looks like an ordered pair.
Looks like an ordered pair. Looks like where I would put a point on a graph, right? So that's why we don't use parentheses, because that's not what this is. These are two different x's. If it's parentheses, it looks like an x and a y, right? So that's why we got the squiggles going on. All right, so what are we doing today? Well, some things are going to happen to my equations, okay? They won't always be in standard form. Maybe I give it to you in factored form already. Maybe it's in standard form, but it's out of order, okay? So it's not always going to be given to you the correct way. The equation also won't always be equal to 0. It might be equal to 2 on the other side, which means I'm going to have to move it over, because if we're solving, it has to be equal to 0. So I might have to move something over before I start to factor. There also might be a greatest common factor within all the terms. So I might be able to divide the whole equation by a certain number, making them smaller and making them easier to fill the grid with. Okay, so we're going to look for these special cases today when it comes to factoring. Questions so far? Okay. First one you have in your book on page 130, it is 3m squared plus 30m minus 168. What do you notice about this guy?
There's two n's.
What kind of jumps out at you? That 168? Yes? That's big. That's usually not as big as we're used to working with, right? If I filled in my table, I would have to end up, multiplying 3 and negative 168 together? I do not want to have two numbers that multiply to give me that and somehow add to give me 30, right? That's a red flag. These giant numbers going on, red flag. So if I see a red flag like that, I should try to do what? They're too big. How could I try to make them small? Simplify by dividing something out of all of them. What could I divide out of all of them? A 3. Yeah. Let's divide a 3 out of all the pieces. Because then when I divide 3, 30, and 168 by 3, I get 1, 10, and negative 56. Would we agree that one might be a little bit easier to work with?
Yes.
I think so. Yep. Is 3 going to give me a solution or a factor at all? Does it have a variable attached with it?
Yeah.
Just the 3. 3 is by itself, right? So it's not going to tell me where it crosses my x-axis. There's no variable attached to it. So once you divide that 3 out, you can eliminate it. You don't need it anymore. Okay? You've reduced your entire quadratic. That 3 is not going to give me a solution because it didn't have a variable with it. So if you can take a GCF out, take it out, throw it away. So all we need to worry about is m squared plus 10m minus 56. That will show me where this quadratic is crossing my x-axis. All the 3 did, it didn't shift it. What it did was it just stretched our parabola up and down. But it's still crossing over at the two same spots. All right?
Parabola.
So now, fill in my box. What's going to go in the top corner? And m squared, the bottom left, or the bottom right, excuse me, negative 56. All right, so we got to fill this in with two numbers. They have to add to give me what? Right here, babe. They have to add to give me 10, and they have to multiply to give me negative 56, this one. So if they add to give me 10, but multiply to give me negative 56, what are we thinking? Okay. Here's a couple of options if you're kind of stuck. Here's some things that multiply to give me 56. There's 2 and 28, 4 and 14, 7 and 8. Brandon's thinking 4 and 14. Is that what you're thinking?
How'd you get to add the 10?
That's the middle piece. So when it was in standard form, m squared plus 10m minus 56, the 10 gives you the add, the piece in the middle. Yep. And then the multiply is your diagonal multiplied together. All right, so we go with 4 and 14.
Yeah.
To get negative 56, one of them has to be negative, right? We're going to make it negative 4 because 14 minus 4 gives us that positive 10 that we need. Come on, pick up the pencil and start writing. Braylon, let's go. We're not doing this today. Come on. We're over here. Okay, we need to leave and go to the office. Is that what needs to happen? I can call someone to come get you if you need. What can we factor out of m squared and 14m? What's our greatest common factor? An m. How about negative 4m and negative 56? Keep going. What? Negative 4. Good. How do I know it's negative? Because that first piece out to the side is negative. Yeah. All right. Now let's do the pairs on the going up and down. What can I take out of m squared and negative 4m? An m. Just an m. Positive or negative? Positive. What can we take out of 14m and negative 56? 14. Positive or negative? Positive. Good. All right, Mason, so what are my two factors? Yep, what is the factored form? What's it going to be? I did all that work to give me what factors? So what's my, what I need to rewrite it with my parentheses. What's going to go in my parentheses?
Okay,
yep.
That's what I was trying to think.
The parentheses are the factors. Yeah. So what are we going to end up writing it as?
I'm gonna say like negative 4 minus negative 56.
What's on the sides? There's an m minus 4 on the side, and there's an m plus 14 on the top. Those pairs, bless you, give me my factors. Keep going. We're not done. All right, now it's time for zero product property, right? Because we're solving. Make each piece equal to 0. Again, how come we're not bringing the 3 back? Because 3 didn't have the variable, so we don't care about it. All right, so what are my two solutions? 4, good, and 14. 4 and negative 14, excuse me. Because you're going to add the 4 over to make it move away from the m. Then you're going to subtract the 14 over to get that away from your m.
Does it matter like what order you put in?
It does not. No, if you had m equals negative 14 and then m equals 4, that's fine. And even your factors, if you have m plus 14 and then m minus 4 in your parentheses, that's fine.
Like the end, like where it's like 14 and 4.
Set notation, technically you're supposed to do smallest to biggest. Yeah. Questions on this one? Yep. Because you have to subtract 14 over. When you have m plus 14 equals 0, listen to me. She's talking to him. M plus 14 equals 0, you have to subtract 14 over to move it away. So that's how you get m equals negative 14. Questions? We're good? We're good? All right. Now we got this one. This looks different. This is very different from what we've been doing. Right? We have x plus 4 in parentheses, x minus 5 in parentheses, and then now it's equal to a negative 8.
Isn't that technically giving us our factor? It looks like
You think it is, which is why I'm showing this to you. Why is it not giving you your factors though? Because it's equal to negative 8. If it was equal to 0, we would have been golden, right?
Yeah.
Just take them, solve, move on. We'd be like, oh, negative 4 and 5, we're done, right? But because it's equal to negative 8, we got some work to do, okay? I need to move 8 back to the other side. But moving 8 back to the other side right now would just give me x plus 4, parentheses, x minus 5, parentheses, and then a plus 8 equals 0. That's not helping me either, is it? Still in factored form. These clearly weren't the right factors since we're equal to negative 8. So how can I fix it? What can I do with these factors? What's our favorite 4-lettered F word?
Oh, that.
Foil. 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 Okay? So we're going to put my factors back together. We need it to be in standard form. Okay? We need to put it back in standard form because we have to fix the quadratic. So x times x gives me x squared. X times negative 5. Negative 5x, 4 and x, and then 4 negative 5. Write this down. Come on. You don't want to look up, it's right here. Okay, so we have it back in standard form, almost. Let's put those two middle pieces together. There we go. So, what would happen if I added my 8 now over to the other side? Would it work? Does he have a friend to get put with?
Yes.
Yeah, because what's the other loose number? 20. So let's do negative 20 plus 8 to move it over. So we have x squared minus x minus 12. When I moved 8 over, it only got added to the other loose number. 20 and 8 are the only like terms. So x squared minus x, not changing. But negative 20 plus 8 is now going to give me negative 12. So this one almost looked real easy, didn't it? When you first saw it, you're like, oh, factored form. But actually, they had messed it all up for you. I know, not nice. So now we're going to factor this new quadratic. Okay, so we have x squared minus x minus 12. Let's use our box to do this one. What's going to go in the top corner? Bottom corner? Negative 12. Yeah. All right, so what are we going to use? What numbers? They got to multiply to give me negative 12, and they have to add to give me negative 1.
Wait, can you use decimals for like adding?
I mean, you could, but we're not going to. We're going to stick with all whole numbers. To say it's not possible is a lie. It could possibly happen. We will not ever do decimals in Algebra 1. Yes. Okay, what are the numbers? Negative 4 and positive 3. Good. Why did she do negative 4 and 3 instead of negative 3 and 4?
Because if you did negative 3 and 4, then you would equal with positive 1.
Good. We need the combination to give us that negative 1. So we need the negative 4 and the positive 3. All right, time to take out some GCS. What can we factor out of x squared and minus 4x? Walter, do you agree? Huh? What can we take out of x squared and negative 4x? Rory says x. Do you agree with her? Yeah, you should. It's right. How about, not what we're talking about. How about 3x and negative 12? Just a 3? Is it going to be positive or negative? Positive. Positive. Good. X squared and 3x? Good, just an x again. And then negative 4x and negative 12. Negative 4, good. So our factors are now x plus 3 and x minus 4. Pretty different from x plus 4 and x minus 5, right? So, different factors to work with. Make them each what? Equal to 0. Solve, and what do we get? Negative 3 and positive 4. Good. Okay, so this one there was a lot of work to do in the beginning. But what could you recognize in the future to kind of give you a hint it might be a lot of work to do in the beginning? It's not equal to 0. And what was the other thing? It was in parentheses. Okay, so this one was already in factored form and it's not equal to 0. So in the future, if that happens again, hopefully a bell goes off, like, oh, this was that long thing. I had to FOIL, move my number over, then factor again. Okay, so if we get factored form equal to not 0, that's what's going to give you the most work. This is probably as hard as it's going to get. Okay, I won't call it hard. I would say more steps. There's more work involved with this one than any of the other kinds. Any questions about it? No. Did you have a question? No? We're good? Okay. Got it? All right, my next one. 6d squared plus 5d equals 1. Okay. Jaguar wants to subtract the 1 over. How come?
Myself.
Yeah, we got to move that guy back over because it can't be by itself. It has to be equal to 0 instead. Is it like last time where I had to FOIL and stuff before I subtracted? No, because the other side is already in standard form. So when I subtract 1 over, though, there's not another loose number to subtract it from, which means it's just going to get put on the end. All right. So this time it was standard form, not equal to 0. So move the piece over. There was not another like term to subtract 1 from, so we just got put on the end. So we have 6d squared plus 5d minus 1 equals 0 this time. Yeah, so 6d squared is in the top, negative 1 in the bottom. We're trying to figure out 2 numbers to add to give me my middle piece, which was 5. And I have to multiply to give me what those multiply, which is negative 6. Good. I feel like these are like little puzzles each time. So what numbers do you think? 6 and 1, 2 and 5. Let's figure it out. 2 and 2. I bet you 2 and 3 is the first thing that jumps in your head because you see 5. Like, oh, 2 and 3, that gives me 5. You gotta be careful though because that 6 is negative. Okay, so we cannot use 2 and 3. We have to use 1 and 5. Which one needs to be negative though? We're gonna use the negative 1. So negative 1 and positive 6. For those 2 pieces in the middle. You good? Okay. All right. Let's take out some GCFs. Yeah, my top. You agree with 60 taken out of the top row? How about the bottom row? Negative 1. Yep. How about that first column? 6d squared and negative 1d. A D, yes. Is it going to be positive or negative? Positive. How about 6D and negative 1?
That's 6. 1.
This is just going to be 1. Yeah. Because they don't both have a D, so a D can't come out. Only thing to divide out of 6 and negative 1 is the number 1. Shh, too much talking back there. Okay, Mason, I'm coming back to you. So what are my, you can do it. You can do it. What are your two factors? How do I rewrite this into factored form?
6D minus 1 and D plus 1.
Yes, sir. Good. Good, good. That is my factored form of my quadratic. Remember, we have standard form, which is the blue, and then factored form, which is after we factor it. All right, Zeke, now what?
Put 6D minus 1 equals 0, and D plus 1.
Abby, help me get the first D by itself. She says add 1, divide by 6, and then how about the other side? Yeah, just subtract the 1. Good. Yeah. So you always move that loose piece to the other side first, and then we divide, right, Zeke? Yeah.
So you add the 1 to the 0. Right?
Yes.
And then you divide by 6.
Yep. Yep. All right, was that one okay? Questions? I think we have what, 2 more? 1 and then 3 the test. And then I got a little 3-question worksheet for y'all. Yes. Okay, here we go. P squared plus 36 equals 13P. All right, so yeah, well, what's on the wrong side? The 13P is on the wrong side, right? Before I move it over, is it in standard or factored form already? Standard, so I can go ahead and move it, right? Yeah. Remember the one that had all the extra steps was if it was factored form. That's not happening. I can go ahead and subtract 13P. Are we going to say P squared plus 36 minus 13P?
No. P squared minus 13P plus 36.
Okay. How come when I subtract it over, why did you move it to the middle?
Because you can't subtract 13P from regular 36.
Well, but why can't I just say P squared plus 36 minus 13P? What's wrong with that? It's not what?
It's not correct.
I'm looking for a certain vocab word. It's not.
Standard
There it is, Shauna. It is not in standard form if it's that way. Has to be in standard form, right? Because there's certain pieces we look for about the whole adding and multiplying. So you got to make sure it's in standard form. All right, now we can factor this guy. All right, we have our charts. Our two numbers this time, they have to add to give me what? Negative 13, and they have to multiply to give me 36. Who has an idea? Some kind of a 9, some kind of a 4? They have to both be the same sign, right? Because of the positive 36. But since we have to get a negative 13 out of them, we're going to do negative 4 and negative 9. Yeah.
Wait, so like if you, so you have to be able to multiply and get 36 and add negative 1.
Negative 13. So when it's in standard form, so that's why it was important to put negative 13P in the middle and in its rightful spot, because that middle piece gives me what they have to add to become.
Why is it P2?
What are you talking about? Because p squared times 36 is 36p squared. Yeah. Guys, can you please stop?
I wasn't looking at the equation.
Thank you.
I wasn't looking at the equation.
Yeah, that's where it came from. All right, what's our GCF of stop? A p squared. DJ, stop instigating it. P squared and negative 4p. What can we take out of that? P. How about negative 9p and 36? Negative 9. Good. All right. And then my stacked pieces, my columns. How about p squared and negative 9p? P, negative 4p and 36.
Negative 2p. Wait, whoa.
Just negative 4. How come it? So 2 is not wrong. It's just not the greatest common factor. Does that make sense? You want to try to find the biggest number that can come out of both of them. How come there wasn't a p with it? Bless you.
36 doesn't have p.
And how come it's negative?
Because the 4 is negative.
There you go. Good. I feel like y'all are getting better at these. Slowly getting there. So what are my two factors?
P plus, or no, p minus 9 and p minus 4.
Yes. P minus 9, p minus 4. Take those pieces equal to 0. What are my two solutions?
P minus 9 equals 0. P minus 4 equals 0.
Positive 9 and positive 4 is what we end up getting because we're adding them both over to the other side. All right. Questions on that one? So what was sneaky about this one in the very beginning?
Wait, no.
Something with the 13p. What was sneaky about 13p?
You can't really multiply anything to get to it, right?
What would be at the very, very beginning?
Oh, yeah.
It was gonna be like on the end, but we big brain, so we didn't put that.
Yeah, good. They wanted you like, oh, they know to move stuff, but do they know where to move it to? So they were making sure that you knew where to put it in standard form.
They tried to bamboozle.
They did. They tried. You were not bamboozled. All right. Let's go to beat the test. Here we go. We have 40x squared minus 30x equals 135. Woo! Check all that apply. Well, what we're going to check are the solutions, right? Okay. Tell me what you see. What jumps out at you?
The 135.
135 jumps out. Why does it jump out?
Because it's a big number.
It's big number. Why else would it jump out at you? It's on the wrong side, right? It should equal 0. So let's move it over. Let's move it over. All right, I moved it over. Do you want to factor that? Because the number was so big that y'all noticed. Y'all, quiet please. Brandon wants to divide it. We're going to divide it by what? By 5, because it's going to make life so much better. Let's get all those numbers smaller. Do I need that 5 anymore? No, he's done his job. How come I know I don't need him anymore? He's on the outside, but what's missing with the 5? He doesn't have an X. Okay, so since he doesn't have an X with him, he's not going to give me a solution for X. So he is not needed anymore. We're going to get rid of him. What we're going to actually factor is 8x squared minus 6x minus 27. Get this one out for me on the side. This one has a lot of steps, so I want you to write this one down, okay? Thank you, sir. All right, so let's fill in that grid. What's going to go in the top corner? Good. Negative 27 at the bottom. So we're still going to get kind of a big number, but it's going to be smaller than 40 times 135, right? So we're looking, so my middle term was 6, negative 6. So my two numbers that I'm missing I have to add to give me negative 6. And then when I multiply 8 and 27 together, I know that my other two numbers have to also multiply to give me negative 216. Okay? Still kind of a big number, but again, smaller than what it would have been if I didn't divide by 5. Okay? So here are some options for you. There's 4 and 54, 8 and 27, 12 and 18.
12 and 18.
The 12 and 18?
Yeah.
I would definitely do 12 and 18. Which one has to be negative for me to get a negative 6? The 18 has to be negative, yep.
12
So those get filled in.
times negative x. No, wait. 18x.
So 12 times 18 is the same thing as 8 times 27. Your diagonals, when they multiply, should be the same thing. GCF time. Top row, what can come out of 8x squared and 12x? The biggest thing. Bigger. Think bigger than 2. 4 and an x. Yep. How about negative 18x and negative 27? There we go. How do I know it's negative?
Negative times negative is way off.
Because the 18 was negative, that's the closest to the number. That means the sign comes with it. Yep. All right, my first column, 8x squared and negative 18x.
Definitely 2. Wait, yeah.
Yeah, I think 2, because you can't do 4, can't do 8. Yep, 2 and the x, right? 2x comes out. And then the last one, just a 3.
3x.
Positive 3.
Negative 3.
Positive 3. Yep. All right, Mason, coming to you again.
Okay.
What are my factors?
4x minus 9 and then 2x plus 3.
Yes. Boom.
I heard something.
All right, looking at your little boxes, do you agree they all have 4, 9, and 2 and 3 in them somehow? Yeah? So before you even started, those kind of give you an idea of what numbers you should have ended up with. Did y'all hear that? Because you know your EOC is not all multiple choice. They have check all that apply. So that kind of gives you an idea of what you should get. What do I have to do from here? Make them each equal to 0.
4x minus 9 equals 0. 2x plus 3 equals 0.
Yep. So how am I going to get the first x by itself?
The first x.
Plus 9, and then
And then plus 9.
divide by 4.
This is what I was going to say.
My other side, we're going to
You're going to add 3. No, wait, add.
subtract.
Subtract 3.
Subtract 3,
And then divide by 2.
and then divide by 2. So we're looking for 9/4 and negative 3/2. When you got your factors of 4x minus 9 and 2x plus 3, you could have eliminated the 3/4 options because they're not together in a factor. So you could have crossed those off. You know those can't be it.
And the negative 9 over 2.
Oh yeah, negative 9 over 2. We could have eliminated that one also. Yep. Good. All right, questions for me before I give you your homework. What? Summary? We're not going to do summary today. No summaries today. Yes. Okay. Let me give you your worksheet. I would keep your notes out. They're going to help you.
Hopefully it's actually Nike.